Hey everyone, I'm Chris, and in this video I want to give you an overview of the new save game system in NeoFPS 1.1. First of all, we're going to have a look at it in action, see what it can do. Then we're going to have a look at how to use it in your own games. Then we're going to have a look at how to extend it with scripts to save new types of components and things like that. Okay, so first up, first type of save we'll have a look at is the manual hard saves. These are the kind of things that you would use in a narrative-based game, for example, if you were faced with a huge choice and maybe you wanted to save your progress so you could go back and try another option. So for example here we get to set a new name, test, boom, save game, and now if we were to go to the main menu, single player, load game, is the save that we just had. So this should load us back exactly where we just were. Then after that, we have the quick saves, which by default is F5. So if I hit that, see the little icon down at the bottom to say saving game. And then F9 will load us back to just where we were. Now the save system can save full game state. That includes things like rigid bodies here. Reload that. Also includes animator state. We reload with that. Keep going halfway through, and it works with things like pooled objects like the grenade here. Save with that. Quick load. Yes, it's a pretty comprehensive system. There's a couple of features that still need working out, like I want to work out how to do audio sources. So for example, character dialogue could be resumed partway through, and also possibly things like particle effects, the larger effects like smoke, that wants to resume again partway through instead of starting from scratch. Third type of save is autosaves. Can't demonstrate those in here, but essentially they work exactly the same way as quick saves, but they're triggered from scripts for things like checkpoints. So if we quit the game and then have a look in the editor, and the first thing that we want to look at is NeoFPS resources, FPS settings, save games. So this is the actual main save game settings, and this is actually also the save game manager, which is referenced from scripts to actually call the save code. The first up, location. This is where the save files will be written to and loaded from. So currently, system data path and data path. Set a subfolder. If we explore to there, then you can see the saves that are currently set up there, that we've currently got recorded. And then the save game inspector here. Now, the NeoFPS save system uses a custom binary format, which is designed to be fast and lightweight, but it's not designed to be human readable. So if you actually want to look at the contents of a save file, this is where you've got to do it. So if we hit open save file and just pick one of these, this is the contents of the save. It's split up into contexts. So here we have metadata and the scene. We open up the scene, all these different game objects, go to those. We've got a component here, for example, and then go back up the hierarchy, so on and so forth. The property names that you see here, these aren't actually written to the file. What's written to the file is the hashes. So what we can do is if we know in advance the names of the properties in our script, then you can put them in this section here, and it will save both the property name and the hash, and then when it finds one that matches, it will print it out in green here. You can then export your property names and then re-import them later on if you're repeatedly having to inspect the same file. You just want to check the contents. Okay, cool. So next up, quick save. So can quick save, pretty obvious. Quick load all, that gives you the option of either when you hit quick load with F9, does it only load the latest quick save file, or does it also load from the latest manual save, auto save, and quick save? None quick saves is the number of quick save files that we want to maintain. So if you reach that limit and then you hit F5, the oldest quicksave file will be deleted once the quicksave is complete. Autosave, just the same. Manual save, pretty obvious again, can you manual save? And then continue from. So in the main menu, there is also a continue option, which will resume from where the game left off. Default options here are continue from latest autosave only, from all saves, or from on. Loading screen. So the new NeoFPS 1.1 adds a Neo Scene Manager, it's called. Essentially lets you load scenes behind a loading screen asynchronously. And the main reason to do that is because if you're loading from a save game, you want to recreate the scene hierarchy, preferably before any of the objects have been initialized. So that's what that does here. It loads the scene and then immediately rebuilds the hierarchy based on the save game and then reads all of the save file properties before initializing most of the objects. The options here are to load by name or by index, and then the name of a scene in your build settings, or the index of a scene in your build settings that you want to use as your loading screen. The loading scene can be anything that you want. It's pretty arbitrary. You just want something that essentially covers the screen whilst you're loading the scene in the background. Okay, thumbnails. If you noticed when we loaded from the manual save, when we went to the save browser in the main menu, you could see images with each of the saves. This is how that's set up. So currently, quick save and autosave are set to use screenshots. You can also use a texture from an object in the scene, the texture setting here, or not. Screenshot size. Textures are quite a large data structure, actually, so you want to keep your screenshots as small as you can get away with. The save system uses buffers, which are split up into certain sizes. So if you were to do an overly large screenshot size, like a full 1920 by 1080, you would not be able to fit that in the save game buffers, and you probably wouldn't want to anyway. Screenshot compression is pretty obvious. And then linear rendering, you want to tick that on if your game is using linear rendering, which NeoFPS by default is. The reason for that is that Unity's screenshot system isn't aware of linear versus gamma colors and saves everything using gamma. So the screenshots in the save browser will appear really bright and wash out. And the final thing is this recreatable items section here. We'll go over this a bit later, but essentially this is where you would register prefabs so that the save game system can recreate them when it's building your scene hierarchy. Right, now the next thing to look at is the Neo-Serialized game object behavior. This is a component that's attached to every game object that you want to save. This includes prefab objects and also objects within the scene. So here, for example, I've selected a prefab within the project list, project hierarchy. And you can see the information box at the top here just gives you the prefab ID of this object, 1544, blah, blah, blah. So if we were to drop this in a scene, then this changes. This is telling us that the object will not be serialized because no scene save info is found in the scene. Serialization key not set, prefab ID, exactly the same ID that we had before. So, game objects in the scene will be saved if they follow a few simple rules. Firstly, they need this Neo-Serialized game object on them. Next, the root object in the scene needs to have a Neo-Serialized game object. Thirdly, there needs to be an object with a scene save info component on it. So, for example, here, we're going to add the scene save info. Then now we look at it again. The object will be serialized, and now it has a serialization key. Now, one of these is required in every scene that you want to save. And it only has a couple of simple options. Firstly, the name of the scene. Nextly, the thumbnail texture. So if you remember in the save game settings, we got to say you can use a texture from the scene for the thumbnail. This is where you would specify that. And finally, the recreatable items is the same as in the Save Game Manager. We'll go through that in a little bit. Back to the NeoSerialized game object. So first up, we want to save the name of the object. This is only required if the name is going to change at runtime and if you want to be showing it to the user. Generally, it's not something you'll be interested in. Next, we look at how do you want to save the transform of the object. So we can save position and rotation in local or in world space, or ignore them. Scale, we can only save in local space or ignored. By default, it's ignored. Next up, how do we want to save the child objects? So, as I was saying before, every object that you want to save has to have a NeoSerialized game object on it. And that includes any child objects that have components that you want to save again. So they don't have to be direct children of the current object. They can be further down the hierarchy. But if you have components that you want to save, they must have this component on them. So this section here lets you filter the objects, the child objects that will be saved. By default, it's set to include all child objects. And then you can filter, you can add objects here that you want to exclude from that list. You can also switch it to include, which means that none of the objects none of the children will be saved, except for any that you add to the list here, as you can see. Actually, I'll just undo that. There we go. Now, NeoSerialized components are any components, any monobehaviours on the object which implement a specific interface, which we'll get to a little bit later on, called the iNeoSerializable component interface. We'll look at that when we go through extending the save game system. But essentially, all of the NeoFPS components implement this interface. If you have control over your own script, then you can implement it as well for a very simple way to add save games to your components. If not, there is another system here, which uses a thing called formatters, which you would use, for example, for the Unity components or for components for scripts in another third-party asset, if you didn't want to modify them. So similar to the child objects, you can filter out which ones you want to include in your save. By default, it's set to include all, and then exclude any that are added to this list. This will list any of the components on this game object that are found. You can also set it to include, which means that none will be saved by default, and then you can include specific ones by adding this list here. The other components, the ones that use formatters, are essentially set up to exclude all by default, and then you need to include them manually here. So for example, here we could include the rigid body, but the character controller actually takes care of that for us, so there's no in this case. Next up on the component is overrides. So overrides are used to allow you to create different types of saves. An example of this is persistence, which is the other save mode that's set up besides the default in NeoFPS. You can extend this as you like, but persistence is one that's used to persist character data across scene loads. For example, if you're playing a narrative game and you transition from one scene to another, you want to carry your health, you want to carry your inventory over with you. So this is how it does that. So essentially this lets you override each of the properties above, specifically for the save mode. So you can set it, for example, here, because we're not interested in saving the position when you're persisting character data across two scenes, we set this to ignore. Most other things we set to use default, which uses the ones above. Here, for example, the NeoSerialized components, we're saying exclude all, but then specifically include the character, the health manager, and the inventory. The rest will all be dropped. Child objects here, we're saying use default, and then as we move up the hierarchy, upper body is saying use default again. Body spring. Body spring doesn't have an override set, so that uses default too. And the aimer here This one's set to only include the item root here, which is where the inventory items are stored. This means that it doesn't include the player camera root. So this will be skipped for the persistence, and the spring will be skipped for persistence. So let's fire up the demo persistence scene, and you can see that in action. So here, for example, you can add some random damage to the player, take away a couple of guns, fire a couple of rounds, and now if we were to load the demo facility scene, we spawn in the standard spawn point, standard facing and everything, but we have the gun selected that we had when we left the previous scene. We've got the same amount of ammo, and we have the same health. So that's the Neo-Serialized game object. The only other thing that we need to think about is how we create objects at runtime. Now, the game needs to understand which prefabs are available to it, and it needs to address them such that when you load from a save game, it can rebuild all of the objects that were instantiated from scripts and then load their properties on top of them. So the prefab ID here on the Neo-Serialized game object component is what's used to reference the prefabs. If we look at the save game settings again, we look at this recreatable items, and we have this drop down here. And this is all of the objects, all of the prefabs that are registered to be able to be rebuilt at runtime. So if you want to add a new prefab to this list, you can drag it into the Add Prefab section here. Alternatively, you can drag a whole folder into this Add Folder section, and every prefab in that folder and in all of its subfolders will be added to the list here. Now, one thing to bear in mind is that any prefabs that you have in this list will generally always be loaded into memory. So if you have a prefab that's only going to be used within a couple of scenes, you can instead go to the Scene Save Info component within your scenes and use the Recreatable Items section here. You can drop your prefabs into this section if they're very specialist objects. Now, the other thing that you have to bear in mind if you're writing scripts and you want to instantiate objects that will be saved within the save game system is that you can't use the standard Unity instantiate. Instead, you need to use an instantiate that's attached to either the Neo-Serialized game object or the Scene Save Info. I'll just demonstrate that quickly here. A new script just to show this. Okay, so first up, let's define what our prefab is going to be. So if we do that, and then we refactoring to pull in the NeoFPS namespace. Right. Now, normally, what we would do, hang on, random code here, good stuff, is you would instantiate by calling Unity's instantiate function. There we go. Okay. And that would be all that you need to do to create an instance of your prefab. Now, with the NeoSave system, you need your prefab to register with its parent object so that the hierarchy can be properly rebuilt. So instead, what you need to do here is we need to grab the Neo-Serialized game object, from the current object, pull in the NeoSave games namespace, and call instantiate prefab from there. There you go. That essentially does exactly the same thing. However, the instance will now be registered with the Neo-Serialized game object that's attached to this script's game object. If instead you wanted to create your object in the the root of the scene instead of with a parent NSGO, you would have to use the scene save info. So option number 3, and we want scene save info, and this is in a different namespace. Save games. And we get the scene save info by build index, and the current object, say game object scene build index. For example, if you want to store your build index, you want to store your scene, or you want to store a reference to the scene save info, equally good. Hang on, instantiate prefab, of course, don't forget that bit. And there we go. Essentially the same. It just means that the game object container that the scene save info contains that tracks all of the root game objects that have been initialized will correctly reference the new prefab. So now if you were to save the game, then this instance 3 would, instance 2 and instance 3 would be tracked, they will be saved, and when you reload the game, they will be correctly rebuilt and reinitialized in the same place in the hierarchy. So that's that. Right, now let's look at how to extend the NeoSave system to save new scripts, new behaviors. Okay, so there's 2 ways to do this. The first way, and the easiest, is to modify your scripts to inherit from the iNeoSerializable component interface. So to demonstrate that, I'm just going to create a new behavior script. And let's edit that. Okay, so here we go. Just clear the contents. And then I will inherit from the interface. Okay. Use refactoring to pull in the correct namespace. And then use it again to implement. And there we go. So this is a pretty simple interface. It's just got 2 methods, read and write. So the reader takes the deserializer, called reader, and the writer takes the serializer here, called writer. So let's just add a property. There we go. Now if we wanted to save that property out, we do in the write properties method, called writer. Write value, give the property a name, simple as that. Now, as I was saying when we went through the save file inspector, the NeoSave files are saved as a binary format, and they don't actually use the name of the properties in the file. So what's actually happening here when you use the string behind the scenes is that it's being converted to a hash. And the way it does that is as such. It's like NeoSerialization utilities, string to hash. So that's the equivalent of what we just wrote previously, and the end result. But the most efficient way to do this is to pre-cache your hashes. And there's a little helper that you can use to do that. So here, for example, I'm going to say private static read only neo serialization key. Give a name. And there we go. So that essentially on creation converts the string to a hash and just stores it there. So we can just pass this value straight in here. And that's by far the most efficient way to reference things. Because it's static, this property will be available to every instance of this behavior. And it will only be initialized the very first time the application runs instead of on demand as you're trying to write your properties. So, to read the property, say reader, try read value. We give it the property key here. And we say output to the prop. And then we can give it a default value if we want, if it fails. So the try read value method returns a bool that says that the property of the correct type was found with this key. And then, if it was, it writes the property from the save file into this value, into this property here, into the parameter here. And if not, it writes the default value. Now the write value and try read value methods support a wide range of value types. So the .NET standard value types, like your ints, your bools, your bytes, your floats, and also strings, and also Unity's value types, so vectors, quaternions, colors. Alongside that, you also have write values. And here you can see this takes an I collection. So you can pass in an array here, and you can pass in a list if you wanted to. So various data types should work with that. And the same goes for try read values, just as with the try read value, same format and everything. Another thing you have, right, serializable. So this is any class or struct with the serializable attribute, which is a pretty standard thing to do when you're writing your scripts for Unity. And then we also have transform reference, game object reference, component reference, and neo-serialize game object reference. So for example, here we could say transform reference. Just temporarily use the same hash. You need to use a unique one for every property, but just because we're demoing here. And we would just pass in a transform to another component. I'll use this one just because it works. And then the path from, we want to pass in this NSGO parameter here. This is actually the neo-serialized game object that this behavior is attached to. And when you're referencing other components or other objects, the save system works by building a path from the root of the scene up the hierarchy towards it. So it needs to know its origin point as well. If the target is on the same game object, then it just stores the hash for the component or for the object itself. So that's the first way to serialize a component. Now that one is only really appropriate if you have access to the scripts yourself. If you're wanting to serialize something like a Unity component or a script from a third-party asset, then you might not want to go in and actually change the script files, or you might not be able to. So the other way that you can serialize components is using what's called a formatter. The easiest way for me to show you that is to actually show you one of the formatters that's already provided with NeoFPS. So here, for example, is the rigid body formatter. If I open that up, it looks complicated to start with, but it's actually pretty simple. So first of all, we need to inherit from neo-serialization formatter, which is a generic type, and we need to pass in the type that we're trying to format, that we're building a formatter for. So here, for example, it's a rigid body. Below that is a section to actually register the formatter with the system. So runtime initialize on load, this is called when the application is first started. In this case, it's set to before any scenes are loaded. We also have an option here, the Unity editor. Now this is conditional compilation, so this will only be compiled, this little bit here will only be compiled if you're building within the editor. And all that this does, static method, and it just registers this formatter with the system. That's it, you create a new version of your formatter, job done. The neo-serialization keys are just as we mentioned earlier when we were talking through your own components. And here we just have the read and write. Now the main difference here is that we actually pass in an instance of the component we're trying to reference. So for example, here for the rigid body, I'm writing velocity, using the velocity key here, and the rigid body from.velocity. And then if we come down here, then we are using the reader to try read from the velocity key out to a vector 3, which we're then setting for velocity. Now, as you can see, the velocity property on the rigid body is actually a property. So it has a getter and a setter. That means that we can't directly use it as an out parameter. So in this case, I'm just using a local vector3 and then assigning it afterwards if the read passed. And that's it. You read and write all of the properties that you want. If you want to, for example, you can add extra logic in here in the read. Have a look at the animator formatter, and you can see that it's a lot more involved because we're actually checking for, where is it? We're looking at the parameters, we're writing those, that's a variable amount, so we're using the name hashes, and then we're actually going through writing layer weights for the different animation blend layers, and also sorting out transitions. So you can actually do more than just reading and writing properties in these methods. Same when we're writing the transitions here. We come down, we have transition keys and we're reading them. And we're actually applying those. So we have crossfades and various things like that. And setting layer weights on the animator. 2 is the animator parameter here. So yeah, you can do a lot more than just simply reading and writing values. You can actually add a bit of logic to properly initialize your game objects in here, both in the animator formatter and in your own scripts. Yeah, there we go. Hopefully that gives you some idea of how to actually expand the NeoSay system to cover any eventuality. If you have any questions, feel free to jump on the Discord and say hello, or ask them in the comments below. I hope that was useful, and yeah, have fun. Cheers.